There are several ways of how we can deal with visual spatial knowledge. In fact, in your projects, you've already come across some of them. So imagine there is a figure here. Here is a triangle with the apex facing to the right. Here is another triangle with the apex facing to the left. So in one view, the AI agent can extract propositional representations out of figures like this. And similarly, propositional representations out of figure like this. So this is a propositional representation, this is a propositional representation. And then the AI agent can work on these propositional representations to produce new propositional representations. So some AI agent can use a logic engine or a production rule to say that this particular triangle, which was rotated 90 degrees, has now been rotated to 270 degrees. So although the input was in the form of these figures, the action here was at the level of propositional representations of these figures. The AI agent may extract propositional representations like this through image processing, through image segmentation, perhaps using some techniques like constraint propagation as well. Alternatively, the AI agent may have analogical representations. And these analogical representations, there is a structural correspondence between the representation and the external figure. So the external world had a triangle like this, and the analogical representation will also have a triangle like this. Notice that I'm using the term analogical representation, which is a separate thing from analogical reasoning. We are not talking about analogical reasoning right now. We're talking about analogical representation. And analogical representation is one which has some structural correspondence with the external world that is being represented. Given such an analogical representation, then I might run affine transformations or set transformations to get this. So I may say that I got this triangle out of that one simply by the operation of reflection or rotation. So these propositional representations in the previous view are amodal. They are separated from, divorced from the perceptual modality. These analogical representations, on the other hand, are modal representations. They are very close to the perceptual modality. In human cognition, mental imagery appears to use analogical representations. What would be an equivalent theory of computational imagery? Human cognition is very good at using both propositional representations and analogical representations. Computers, however, are not yet good at using analogical representations. Most computers, most of the time, use only propositional representations. The same kind of analysis may apply to other perceptual modalities, not just to visual images. So here are two measures, and we can either extract propositional representations out of them and then analyze those propositional representations, or we could think directly about the relationship between these two particular measures. Here is a question for building theories of human cognition. When you're driving a car and you listen to a melody on your radio and you're reminded of something, reminded of a similar melody that you had heard earlier, what exactly is happening? Are you extracting a propositional representation out of the melody that you just heard? And then the propositional representation reminds you of the propositional representation for a previously heard melody? Or does the new melody somehow directly remind you of a previously heard melody without any intermediate propositional representation? These are all open issues in cognitive science as well as in knowledge-based AI. In cognitive science, there is by now significant agreement that human cognition does use mental imagery, at least with visual images. But we don't know how to do mental imagery in computers.